In section 14, we're exploring how to solve linear equations. And we've already looked at how to solve linear equations by reversing operations. And that works wonderfully when we have only one x term. In the problems we're going to look at today, we don't have that situation. We have multiple x terms. Now, in this first activity, we're going to see x terms that are all on the same side. So we're going to simplify one side and then solve. In the next activity, we're going to look at how do we do that when we have variables on both sides of the equation. So in our model here, or I should say our models, we have two problems. One has 2 times 5 minus x minus 3x equals negative 25, and the other is this one over here on the other side. So to solve this, the first thing we want to do is do any kind of simplification we can do, combine any like terms that we've got. So my first step here would be to multiply the 2 to the 5 and the negative x. So we're going to distribute. And we'll get 10 minus 2x, and then minus 3x just comes along for the ride. In the next step, we can combine like terms. Negative 2 and negative 3 would give me negative 5x. Again, the 10 is just there, didn't combine it with anything. Now to solve it, then we can apply our reversing operations. So we can subtract 10 from both sides, and then divide by negative 5. And we get x equals 7. In Model 2, very much the same type of thing, where we're going to distribute that negative 2 to the first set of parentheses, and the negative 5 to the second set. So we'll get 6x minus 8, and that's from the first set of parentheses, and negative 10x minus 5 from the second set of parentheses. Combine your x terms to get negative 4x, and combine the number part, negative 8 and negative 5 is negative 13. And that equals negative 9. To solve this, again, apply reversing operations, add 13 to both sides, and then divide by negative 4. So let's take a look at a couple examples where we have to kind of go from the beginning, and then we're going to graph it at the very end. So let's take a look at one that's a little bit on the challenging side. Let's start with number 5, just to kind of go with that, with the negative that we have to distribute. So again, we're seeing multiple x's, and they're all on the same side, which is good news for us, but we still have to do a little bit of work to get it into a place where we can reverse operations. So the first thing I'm going to do is distribute my negative 2. So I have 6 plus x minus 10 plus 2x equals 38. And again, I'm getting that from distributing negative 2 to both those terms. My next step is to combine like terms. I have a 1x and a 2x, that's a 3x. And I have a 6 and a negative 10, that's negative 4. And that equals 38. At this point, I can apply reversing operations. So I see that negative 4 I want to reverse by adding 4. And then I'm going to divide by 3. There we go. And I'm going to get x equals 14. So that's my solution, 14. I'm going to put that on my number line and graph it. On number 7, same type of idea, except 2 times we have to distribute. So we're going to have 2 sets of distribution with the 2 and with the 4. When I distribute the 2, I'm going to get 14 minus 2x. And when I distribute the 4, I'm going to have plus 8 plus 4x. And that's going to equal 12. In my next step, I'm going to combine like terms like I did in the previous question. So negative 2x and 4x gives me 2x. And a 14 plus an 8 is a 22. And that's supposed to equal 12. Now, to reverse, I'm going to get rid of plus 22 by subtracting 22. And I get 2x equals negative 10. Divide by 2. And I get negative 5. So again, our first step is distribute anywhere you need to, combine any like terms that you've got, and then you can apply reversing operations to solve this. Now that's what happens when we have variables on one side, but we're going to get into more challenging ones where we don't quite have it so easy. We're going to look at problems where we have it with variables on both sides of the equation. So we've got multiple x's going on in this activity here. First thing we're going to do is, just like in the previous one, we are going to distribute anything that we've got out in front of parentheses. So distribute 4 to 1 and 4 to 5x, so it's 4 plus 20x. Then combine like terms, so we have a negative 8x and a 20x gives us a 12x. And there's nothing else we can do at that point before we get to solving it. We'll work on solving that in just a moment. Same thing in model 2. We're going to distribute the 4 to the 1 and the negative 3x, giving us 4 minus 12x. We can combine like terms. Negative 4 and negative 2 is negative 6. And here we've got a negative 2 and a negative 12, which will give us a 14x. Again, variables on both sides, and we'll talk about how to get that next. So once we've got that set up ready to go, we have to make a decision. What side do we want the variables on? And I'm going to strongly encourage you, move the variable first. Technically, yeah, you can move the number first. So like if I wanted to move that 4 first, I could do it. But it's just kind of dangerous because we might have to end up moving it back over to the other side. So our first strategy would probably be to multiply move the x over to whatever side we want to first, and then move any numbers over. So in this case, because I've got a positive 12 and a negative 6, I think it'd probably be easiest if we move the negative 6 over here. And the way I do that is to reverse subtracting 6x by adding 6x. And when I add 6x to 12x, I get 18x. Now I'm left with this. These x's here are going to cancel out, which is what I want to happen. And to solve this, I'm going to take this 4 away by subtracting it. And I'm going to have negative 14 minus 4, which is negative 18. And then divide by 18. And I get x equals negative 1. Similarly, on model 2, same idea. If I bring the 14 to this side, I'm going to have a positive coefficient on x, which is what I want. You might get in the habit of always moving the variable to the left. Not necessarily the most convenient thing to do, but it works. You just might have more negatives that you don't necessarily want to have. So I bring the 14x over by adding it. And that gives me 8x minus 20 equals 4. To reverse, I'm going to add 20. 8x equals 24. Divide by 8, and x is 3. So let's take a look at a couple problems here, just work them through, make sure we've got the concept down before we move on to the next part. Let's take a look at number 3. We've got 4x minus 40 equals negative 14x plus 14. Again, I want to make a decision which side do I want to put the equation, or the variable on. Because I've got a positive x on this side and a negative 1 over here, it's probably easiest to move the negative 14 over. And the way to do that is to add 14x to both sides. When I do that, I've got 18x minus 40 equals 14. Now I'm going to apply reversing operations. So I'm going to reverse subtracting 40 by adding 40 to both sides. And then I'm going to divide by 18. X is 3. Once I get that variable, that solution, I can always plug it back in and double check and make sure that it works, that the left-hand side and the right-hand side truly are equal. If they're not, I probably have a calculation error somewhere, or maybe it's a big conceptual error. Number 5, we have 7x plus 38 equals 8x plus 32. So I'm going to show you a way that I potentially probably wouldn't want to do it, but I'm going to do it anyway to show you that it does work. It just might get a little bit messy. So I'm going to move the 8x over to the right-hand side. I'm sorry, the left-hand side. So subtract 8x from both sides. and I get negative x plus 38 equals 32. If we apply reversing operations, we're going to subtract, I lost my pen there. We're going to subtract 38. And then because I have a negative in front of there, it's actually a negative 1x. There's that coefficient there. I'm going to divide by that coefficient, which is negative 1, and I get x equals positive 6. Now, I told you that I probably wouldn't normally do it this way, but I wanted to show you that it does work. In reality, I think I would move the 7x over to the 8x. Because when I move that 7x over to the 8x, I know I'm going to have a positive x left over. What oftentimes will happen when we do a problem like this is we'll get through all the steps correct, but we'll lose signs periodically. We want to try and avoid that as much as we can. So a common mistake here would be 7x minus 8x is x. It's not, it's negative x. Or in the next step down here, when you bring all this stuff down, you're focused on subtracting the 38, you've got the negative 6, and then you lost that negative sign. So these are things that happen that we want to try to avoid. That's why I generally like to move the variable to whatever side will give me a positive coefficient on x. Now in part 2 of this video, we're going to take a look at solving the equation and then doing something a little bit more with it. What happens when we have equations that aren't quite linear, but we can get them to be linear? And then what are some special cases? What happens when maybe we don't have a solution?